My name is Markos Markakis, and I'm a fifth-year doctoral student at the Data Systems Lab working with Tim. And most people, when they hear about data systems or databases, they think of somebody in the basement writing SQL. But data is all around us. When you use ChatGPT, that is a model that is stored as data that needs to be loaded somewhere quickly. When you use your Apple Watch to collect your steps or to listen to music, there is data that needs to be streamed back and forth. So data systems encompasses a vast, bigger space than what people usually think about when they think about databases. So currently, I'm involved in two projects. The first project I'm leading and is advised by Mike and it's called Logos. It's about applying causal reasoning on log data to quickly extract insights about large systems. The second project, led by Jeffrey Yu and advised by Tim and Sam Madden, is called BRAD. It's about how to automate the design and maintenance of your cloud infrastructure to reduce costs while reaching your performance standards. Anyone that has ever programmed has tried debugging by print statement, where you try to insert prints in your code, and then hopefully by their sequence or presence, you determine what the fault is. In large industrial systems, this takes the form of logging, so it's an append-only file with timestamp messages of important events. Of course, this means that you have a huge volume of logs to look into every time you need to diagnose something. In Logos, we try to use causal reasoning to automate this process and make the gap between your huge volume of logs and your insight faster. Most of today's production systems include different layers that include a variety of different systems, each of which produces a huge volume of logs. The idea is that it can be difficult to recreate a situation, so you might as well capture all the data about it the first time it comes around. However, the volume of data this creates and the amount of spurious correlations that can come up in this data is huge. What we do in Logos is we try to use causal reasoning to prune the spurious correlations and try to extract the actual insights out of this huge volume of data. So as more workloads have moved to the cloud and as there is a proliferation of different use cases, providers have started offering different engines specialized for these pieces of the workload. The problem is that no real customer and no real user only has one type of workload. What this means is they have to mix and match different things to create their own custom infrastructure. Doing this cost efficiently is very challenging for the average user and even for big companies, eroding the benefits that the cloud is supposed to deliver in terms of cost and ease of use. So there is a saying in computer science that most problems can be solved by adding one more layer of indirection. BRAD essentially does this for databases. So we no longer write binary, we write C and it gets compiled down. We no longer have to pick a machine on the cloud, we have virtual machines managing this. We do the same thing for databases, where you no longer have to program for a specific database, but you program against BRAD, and then we, under the hood, place your workload on the correct engines in a cost-efficient way. As compute becomes cheap and storage becomes even cheaper, people start collecting as much data as possible, and it has been shown through models and through different applications that this data is actually useful in producing good insights. However, if you don't redesign your systems to adapt to this new volume of data, you can end up just being blocked by this huge deluge of incoming things. My hope is that through my research, I can improve our data systems ecosystem, so we can help actually bring us to a reality where we can extract these insights out of the data. So the goal of designing data systems is to optimize real workloads on real data, and it's really challenging to do this in academia because much of the data today is collected by commercial providers. So my hope is after I graduate my PhD to move into an industry research position where I'll be able to tailor systems to actual workloads. So everybody here tries to do their best to move their research forward, but there's also the human aspect, and keeping these social connections alive is very important to me. As such, I've been involved with the Hellenic Student Association ever since I've been at MIT, and I'm presiding this year. And we try to bring Greek and Cypriot students together, and also other students interested in Greek culture, to have roughly one event per month, with the capstone event being our Greek Easter that attracts over 300 people. My ideal future role involves a technical component that I think my PhD is going to help me in, but I also want to be in a function that lets me touch the business side, so to speak, and to interact with customers and users. And I think being part of a club where you have to plan events and to do sort of more logistical things is a good preparation also for this more hands-on part of a role in the future. The overall theme of my research is to make cloud programming easier so that you can focus on your application instead of trying to configure or debug your infrastructure. In that sense, BRAD helps you configure your infrastructure and save on costs, whereas Logos helps you, in the case that failures occur, to diagnose them quickly and find out what's wrong. I think being a researcher is a unique opportunity to be more creative with what you want to do and to tolerate more uncertainty than you would in industry. I think I'm going to miss this after graduation, but I've been glad for the chance to take my time and explore things I'm into. So being a part of CSAIL is amazing because, especially during academic semesters, you can just walk downstairs and attend a world-class lecture by an expert in a subfield that you might not be an expert in, but you can definitely learn from to improve your own work.